Okay, so like I was saying, it's more difficult, but it doesn't matter, because you just have to try your best. Some of you will try your best, some of you won't. That's life. Anyways, we're starting with calculus, which is what you were doing at the end of the last semester. So we're going to continue first with differentiation, okay? And something today we're going to do, first class anyways, the product rule. So, in the last semester you learned how to differentiate something like this. You know this, and you also learned that, for example, derivative of EX is, gosh, you know what, I'll use a different letter, is EX. So it seems like we should know what the derivative of x squared EX is, doesn't it? I mean, after all, we know this derivative and we know this derivative, so why don't we know both? Well, the first thing to tell you is it's not this. In other words, if y equals f times g, the derivative is not f derivative g derivative. Okay, so that's not the rule. And I can show you with a simple example why it's not this. So for example, if I said y equals x squared, that equals x times x, yes? No, I think you're in the room over there, yeah? So the derivative here, if we are using this rule, it should be 1 times 1, which of course is completely wrong, because we know that the answer should be 2x. So this is definitely wrong. Okay, it's definitely not this. So we need to find out what the rule is. Okay, so now we have a little bit of motivation. This I need you to carefully write down. So we're going to have a look at the rule, okay? So we'll start with the proof. Y equals fx gx, and we want to know what the derivative is. Yeah. So, do you remember how to calculate derivative using a special rule from semester 1? First principles. Yeah. So what's the first part here? It's fx plus h g x plus h minus
f of x.
Yeah.
G.
Yeah. All over
H.
h. So we need to simplify this. Okay. So we have fx plus h gx plus h minus fx, I'll use that in a different color, minus fx gx plus h plus fx gx plus h minus fx gx all over h. Okay, so I'll pause for a minute there. So what I've done is I've added and subtracted the same thing into the middle. So together these two make 0, because they can cancel.
How did you?
I can just put them in because one is a positive, one is a negative, and they'll both cancel. So it doesn't change the value on the top. But the reason I did that is because now I can simplify. Because if you look, what's in common here and here? Which gx plus h. And what's in common here? F of x. So my next step is to take out g x plus h and I'm left with fx plus h minus fx plus, and I'll take out fx, and I'm left with gx plus h minus gx all over h. Okay.
Do we need to know how to prove this?
No, but trust me, it's good for your education, so you should still write it down. Let me just separate out like this. Fx plus h minus fx all over h. Oh, Miss Sharif, you're not writing anything. I told you to write this down. You make me so sad. Fx plus h minus fx over h times gx plus h plus fx times gx plus h minus gx over h. Now let's see who's awake. When I make h go to 0, what does this piece become? No.
1?
No.
Can you make what?
H 0.
0?
f of x minus f of x 0 gx plus h
Mm-mm.
1
Mm-mm.
because
Derivative of f. Wakey wakey, yeah, of course. Wake up, wake up, wake up. And this one becomes
The f of g of x.
just g of x. F of x. And this one? This one? Derivative of g. So we found our rule. This is the derivative here. So in other words, if y equals f times g, then the derivative of y is f derivative g plus f g derivative. This is the result. This is called the product rule. Okay, you wrote this down? Yes? Yeah? Okay. Let's have a look at some examples. So, this example, we know the answer already. If y equals x squared, what's the derivative? It should be 2x. Let's test the rule. Y equals xx. This is like f, and this is like g. So the derivative is, firstly, the derivative of f. What's that? 1 times g plus f, which is x, times derivative of g, which is 1. X plus x equals 2x. So we can see the rule works. Now, of course, you don't use the rule for these problems because you know what the answer is already, but I did this as an example to show you that the rule works. Now let's look at our original question, x squared ex, where this is f and this is g. So the derivative Derivative of f, 2x g plus f, and derivative of g, ex. So the answer is 2x plus x squared ex. Got that? Yeah. Let me give one more and then I want you to try one. So let's say we have something like y equals, I don't know, x cubed sine x. So that means y derivative would equal 3x squared sine x plus x cubed cos x. And if you like, you can take out x squared, if you like. So that would leave you with 3 sine x, x cos x.
How do we do the last part?
Which part?
The last.
You mean here to here?
Yeah.
Oh, my heart. This is an x squared, and there's an x squared in here. You're taking out the x squared. Factor out. You've heard this before?
Yeah.
Yeah, so there's an x squared in common to both.
Okay, so we get the x squared then.
Yeah, that's it. Factor out the x squared. Okay, I'll give you one to try. Try this one. Find the derivative if y equals, we'll say, x log x. See what you can do with that.
Is there a note?
Any what?
No.
Ah, you mean like a workbook?
Yeah.
All the worksheets are on Moodle. I don't print. You know I don't print, like in physics. If you want me, I can print.
Sorry, how to change ln to
In 1 over.
What's the derivative?
1 over.
Oh, you should know this.
yeah,
1 over x is the derivative.
just 1 over.
Just 1 over x.
Thank you.
You're breaking my heart.
No,
No!
but I think you need to booklet.
Oh no, you should know these. No, you should know these. Okay, you got this one finished? Ah, it must be Iyad. What the heck happened to you? Traffic? Where are you coming from? Okay, come on. We'll go easy on you for the first class back. Maybe not the second class though. Okay, do we have this one finished? Right. What's the answer?
ln x plus 1.
Log x plus 1.
Looks like it. The derivative would be 1 log x plus x times 1 over x, which would be log x plus 1. Okay. Now, try this one. I'll let you think about it. Differentiate y equals sine x squared.
So it's like sin x multiplied by sin x.
Correct, you've got the idea. Got it?
Yeah.
Alright, let's have a look. What did you get?
2 in cosec.
Yes. So the trick was, as you spotted, you should change this into sin x sin x. So then the derivative would equal cos x sin x plus sin x cos x, which is 2
Isn't that also
sin x cos x. Huh?
cos when we move from side to cos? Minus or?
No, no. It's the other one you're thinking of, cos to sine. Yeah. Okay. Now let's see how you deal with this. Ex sin x cos x. I have to think about what to do when there's 3. Figured out what to do?
No.
Oh, for one, you gave me the wrong student number on your assignment. Your student number should start with a DB.
Sorry.
Yes. Do you know this number? Alright, did anyone figure out what to do here? Wait, okay. Got an answer? No? Okay. Got an answer? No? You have one? Okay, go on, explain how to do it. Go on, don't be shy.
I think I'm wrong.
That's okay. Let's hear your idea.
I put the EX out and inside, yeah, semicolon, and then E.
Come on, use words. I don't understand this and that.
I don't know.
This?
Yeah.
Oh, come on, you must know this one. It's the name of the chapter. Derivative.
Derivative.
Yeah, derivative EX?
No.
Right, derivative, this one. No, use your words.
Derivative is equal
EX, yeah.
Yeah, and inside two semicolon. It's the answer of the.
Yes, of course, yes.
Yeah, so it's the answer.
No, it's not. You're
Yeah,
right. No, you were right, you were wrong, yeah.
But the E is the same.
True. So, you have the right idea. You should break it in like this, F and G. So, Y derivative will be F derivative, which is EX times G, plus F times G derivative. And as Fuang said, this was the last one you did, wasn't it?
Yeah.
No,
Yeah.
last one you did was sin x, sin x. Anyways, the derivative of sin x cos x, you can use the rule again. So that would be cos x, and then plus, no, it would be minus sin x, sin x. So in what you're doing is, this is f derivative g plus f, and this is g derivative. So you need the product rule again here for this part, because it's another product. So it's like you have two products.
So what if we have something instead of the E that doesn't stay the same? Is it going to be
The same idea, yeah. So this will be ex sin x cos x plus ex cos squared x minus ex sin squared x, which will be ex cos squared x plus sin x cos x minus sin squared x at the end.
Why is the minus?
Yeah, because derivative of cos is minus
Minus.
sin. Okay. Wrote that down? No more back move. Okay. Now, maybe I should give you a really hard one.
So this is harder than just like this.
Oh no, these are just section A. This isn't even a section A question. Section A question is more difficult than this. Okay, let's see. We think okay. Find all turn-in points of y equals e minus x sine x in this domain, x from 0 to 2 pi. Now we're talking. Finished it? How many answers did you get?
No, I'm the derivative of the domain name. I understand.
The what now?
The domain name.
Oh, I just mean the x between 0 and 2 pi. So don't give me any answer outside of this. If your answer was bigger than this, reject it. That's all I meant. You got this one finished, Musharif?
Yeah.
How many answers did you get?
I think I can find 5.
5?
Yeah.
What?
I was only expecting 2.
Really?
Yes, really.
Then 0 and 45.
Oh, no, first thing, it should be in radians. Radian.
Okay.
Yeah. You know this word, don't you?
Yeah, I know.
Do you? Sharif, you didn't even give me a student number.
Because I didn't have.
Oh, but then that means I have to find it. You've just given the work to me instead of you, that's all.
Sorry, but why we need to write again?
Why?
Uh-huh.
Didn't you learn anything with Roland? No, the reason is, in derivatives, you know when you say derivative of sine is cos. Below. That's only true when you're using radians. It's not true when you're using degrees. This is only true in radian mode. Alright, let's have a look at it. Anyone feel like they got the answer? Okay. So, firstly, derivative. dy dx. Derivative of e minus x? Who knows that one?
Minus E.
Minus e minus x sine x. Plus e minus x derivative of sine x. If I want the turning point, what do I do? Very good. What's next?
If you 2 minus
So-
X out.
Yeah, I can take e minus x out. Minus sine x plus cos x equals 0. Or in other words, bracket e minus x bracket cos x minus sine x equals 0. Okay, what's next?
Will you multiply that?
No, because we just took it out. So.
Either e minus x equals to 0.
Yeah, either e minus x equals 0 or cos x minus sine x equals 0. Now this one actually can never equal 0, so there's actually no answers this way. It must come from this one. So what do I do next? Well, I can say cos x equals sine x. I can divide both sides by cos, so I get 1 equals sine x over cos x, which is what? Tan x. Now, I don't know how you learned to solve these with Roland. Did you use this circle thing?
Yeah. Okay.
Yeah, I don't show my students this way because it's so confusing. So, the way I do it, you might have to watch the video. What was this lesson called? Like,
Oh, is it erase? Wait, what was
IESF.
Yeah.
You saw this video.
Yeah, I did.
Yeah, simplifies and the last one.
Fix, yeah, much more straightforward. So the first thing is inverse. So x is tan inverse 1, which means x is pi over 4. Extra answer. Do you know how to get the extra answer for tan?
3.
Plus what?
36. For tan is 180.
Plus 180, correct, which in radians is pi. So plus pi gives you 5 over 4 pi.
How is 5?
Pi over 4 plus pi.
Oh.
Yeah, that's the e done. Simplify, do I need to simplify? No, because it's not like a 2x. So it's already simplified. And do I need to fix any of the answers? No, because they're already between 0 and 2 pi. So this is the two answers, although I haven't calculated the y yet. I've only calculated the x. So I need to put these answers back into e minus x sine x. So that would be e minus pi, and sine pi over 2 is 1 over root 2. And then this would be e minus 5 pi over 4. And then, I don't know, what's sine of 5 pi over 4? Let me check it. It's the same thing except with a minus. So the answers are, now you can give it as a decimal or other forms, but for me I'll just give it as pi over 4, e minus pi over root 2 is the first answer, and 5 pi over 4 minus e minus 5 pi over 4 over root 2. So these are the two turning points then.
How
Yeah.
did it, after you calculate what x equals?
Yeah.
How did you?
Do the y, sir.
Put it in here. I know the x, so I can get the y.
So,
How did you?
x is pi over 4, but
the-
you have
Wait,
written
hang on. How did I what?
How did you put the x?
What do you mean how? So put the x in here. So if x is pi over 4, then it's e minus pi over 4 sine pi over 4 is the y.
Okay.
You know this. You know this. I know you know this. I believe in you. So what's your question?
And then you
Yes?
put pi equal 5 over 4, right?
Yes. So this one gave me this answer, and this one gave me this answer.
How did you get the answer?
Oh, dude.
After you put it in the
What do you mean? I took my calculator out, and I put the x in.
and you get the answer with the calculator.
Yes. Now the calculator can give it to you in many ways. Part of it I did in my head, part of it I used my calculator. You can give the answer as a decimal if you like. If this makes you feel better, then you can give it as a decimal. When you can't give it as a decimal is if the question asked for the
Yeah.
exact answer. Yes. Then you cannot. But
Why? Yeah, the question
Can
was
you show the beginning, please?
did Roland not tell you this? You knew this.
Yeah.
Exact means no decimal answer.
okay.
Okay, the derivative of e minus x is minus e,
Correct. Also from semester 1.
minus ex.
Yes.
E minus x.
Minus e minus x. Yes.
Can you go through?
How far? This is the whole thing. Oh, my heart is so fragile. And now I have 12 hours of you. I don't know if I'll last. You wrote all of this down, Swan? Still writing? Okay. So what time are we really at then? Yeah, perfect. That clock has stopped, don't worry. You haven't been here for only 5 minutes.
I wouldn't say.
Alright, can I close this now? So, you have the questions on Moodle. Yes? Now, before you start that, Roland probably gave you questions every night
Yeah.
from the worksheet,
Yeah.
the same worksheets I have.
Yeah.
Yeah. How many questions would he give you? 5, 10, 100? Really?
Yeah.
Only 5?
Yeah.
Oh, he used to go too much into my
Did he really?
Like 7.
Pence.
Yeah.
Anyways,
Depends on the lesson.
of course, yeah. So, some people might say it's a mistake, but I'm going to treat you like adults. Now, yes, I know you're thinking, no, Mr. Stephen, no, we're not adults. But no, I think I need to treat you like adults. So, I'm not going to set homework for you to do. I'm not going to give you particular questions to do. It's going to be your responsibility for semester 2 to manage your own homework. You do some questions that you feel are appropriate. Now, the reason I do this is because in semester 1, I do this every year. In semester 1, students may not know what's expected of them to achieve the grades that they want to achieve. So, I say you should do these 10 questions or whatever to give students an idea of what a homework should look like. But I don't want to be doing this in semester 2 because you need to manage your own time. Maybe one night you have lots of chemistry homework, so you do less maths, and then the next night you do more maths. I need to give you the power to manage your own homework because your semester 2 is going to be quite busy. You still have some assignments to do, but you also need to be preparing for the final exam, which is worth 70%. Okay, so I can't be giving you homework every night like in semester 1. You need to manage it yourself. Now, Roland gave you the same amount that I gave you. So if this worked for you, then you can continue. But if it didn't work for you, then maybe you need to be thinking, I should do more questions. Okay? And if you found this difficult, then you need to practice more questions until you find it easy. Because like I said, this is only like a section A question. In fact, it's not really a section A question. It's not until the next lesson do we have enough maths to do a section A question. Okay? So, I'll let you look at Moodle now. I'll let you start some of the questions now and pick some questions that you should do for homework then. Okay? And we'll give you 10 minutes of that, about 10 minutes, and then we'll start the next lesson then. Okay? And I'll give you a clue. Your exam results weren't fantastic, so just remember that for when deciding how much to do.
No?
I was thinking of physics. I'm assuming your maths grades are going to be similar to your physics, or are you going to tell me now your maths is going to be much better than your physics?
My math? Definitely not.
No, okay. Not yours, maybe. Anyone else feel like their maths grade will be much higher than their physics? This is okay. You can tell me the truth. I won't be offended. I know it sometimes happens, especially if you like maths and you're good at it. Fawn, do you feel like your maths will be higher than your physics grade? Probably, yeah. Less English and maths, huh? Yeah. Iyaz, what do you feel like the relationship is between the two?
Not too far.
Not too far, okay. Mir?
Physics like.
But I mean, compare the maths to the physics. Will your grade be the same, higher, or lower, do you feel?
Same level.
No, not higher?
Maybe a bit higher, but not too much.
Yeah. That's usual actually. Usually the maths grades are higher than the physics grades because of the English. You know? Because in maths there was probably was there any words you didn't know in maths? Really? Many? But did it stop you doing the question?
Yeah, you made me stop the question.
Oh dear. Okay, that's a problem. Do we have physics later today? Tomorrow? Okay. I think what I'll do in physics is I might go through the exam first before doing anything else. So you can see how to do the questions then. Alright, I'll give you